All right. So we are going live. And not sure if you guys can hear me, but it looks like there's audio. So we want to look at what's the difference between centralized and decentralized, right? So let's show what is a decentralized network and what are we trying to go for? What is everyone talking about here? Well, let's look at the original design and then what kind of what happened. So let's try to draw like kind of a decentralized network that you would usually see on a Google search, right? You have a couple of these nodes here. Maybe some of them are bigger than others. Maybe you have direct transactions that are just transient connections. You're not going to be consistently connected with someone, but your phone is going to interact with their phone. And then you're going to have some of these bigger connections. Okay. Now the problem that you see already is somebody can take something like this and they can cut it. Just on one little spot. And you have to have all the flow checking for double spending going through that one spot. So decentralized or full node mesh. What are we really talking about here? Are we talking about decentralization or full node mesh? Is this a full node? If it is, well, then the BTC people will say, well, we don't want them to get too big, so we want to try to make some of these also full nodes. The problem is those are just going to be wallets, and if you add them, you're going to have a mesh. You're going to have a lot of full nodes, but they're not going to have a really good consistent connection that efficiently finds you double spends. So let me show you guys what I think the vision was for Bitcoin, okay? What you have is you have a lot of full nodes, okay? Maybe you got one over here that's United States, right? Maybe you got one over here that's a China one, right? Or whatever. Maybe you got a Japanese or something. But these are going to be well established and they're going to be large full nodes. And the BTC Lightning people will say, oh, but that's a centralized network. Well, hold on. This one's peer-to-peer. Okay. Now, not everything is necessarily connected to everything else, but they're going to be very highly connected. Okay. So this one is going to want to connect with a few. Okay. Each one is probably going to want to connect with like 3 or more because otherwise it's a liability. And it's also not going to be as efficient, as quick. So you're probably not going to have a node, I would assume, being connected to just 1 or 2 other nodes. It might be 3 or more if I had to guess, because then you can propagate information faster. There's going to be some kind of limit to that because eventually it's going to be more efficient to get some information relayed through some of the people you're already connecting to rather than trying to connect to every node. But that doesn't mean automatically that it's going to limit it to just 1. So let's talk about the wallets. Okay, so you can call these peers if you're talking about the Bitcoin white paper title, because I'm pretty sure Craig one time mentioned that that's what it was mentioning when it said peer-to-peer. It was talking about these full nodes being the peers that are communicating directly with each other, and they're not centralized in the sense that you pick a subset of them and the network somehow depends on that. No, this is actually what is meant by decentralized, where there's not one center node. In fact, this right here is centralized, because if you take out one of these two full nodes right here, you've already lost your connection to the other side of the network. Here, you connect to this side of the network. The only node that you have to trust here, if you're this peer, is this one and that one. But if this guy connects to two different full nodes, if that's a secondary node, then suddenly you have multiple paths and you can remove any full node that you want, and you still haven't had any interruption between you and this other side of the network that you're checking for a double spend. Now, if you're spending money, it's the same as me sending a transaction directly to him, actually. So you don't need the Bitcoin network to even do that. You just need to find some way to send it to him. You could use the Bitcoin network, but ultimately you just need to get the transaction to that other person, to that other wallet, right? So if I'm going to send a transaction here, I don't need to be connected to the full nodes. This guy is going to report it, and he's going to get a response, and he's going to be able to double check any double spends, because these full nodes are going to tell him if there's a double spend happening. If we're talking about this system, how is that going to propagate around? Even if you had a system like Caspa, where they have different blocks being produced at different times, different kind of locations, and you got to combine them together, how are you going to propagate the double spend? Okay, so you got to decide, is the Bitcoin network an internet network? And if it is, isn't it going to be highly centralized? Because aren't you always looking for specific information that's going to have to come from a specific peer? Or is it going to be some mesh that we're creating? Now, I came up with a protocol idea, and it's not money, it's reputation. But guess what? It does not need a blockchain at all. There's zero blockchain. It's just peers. And say a peer has, say you have a sphere of influence, you have your community, you have people that you do business with, right? You have like a sphere of influence, right? You transiently connect with these other people by doing business with them. And the protocol that I came up with, there's no blockchain, there's no checking for double spends, because if you think about it, checking for double spends has nothing to do with checking whether somebody signed something that's associated with a public key, with a private key. When you check a public key, you already know the private key associated with it. So if you do business with different people and somebody reports something and they show something that they're signing as reputation for somebody else who you do business with, who has a private key that matches that statement, boom, you have all the information. There's no blockchain necessary. There's no scammers that can give each other reputation, because they're all going to have to do business with you, because you're going to do a computation which starts at your source in the graph and gives reputation out from how you define. Everyone defines reputation from their point of view, and it spreads out and assigns weights according to their own self being trusted first and everybody else not being trusted, and then it balances out from there. So, or I should say, it assigns all the information from there. So you don't always need a blockchain. So you have to think about, what do you actually need a blockchain for? What's actually going on that we actually need a blockchain? And by the way, if you guys think that I should propose something to Craig or someone else to invest in that, hey, I don't want to be stuck trying to desperately find someone to tutor math to, or drive a truck, or do all these things for income. I, try to have roommates and stuff. I really want to, work on what I study, math and computer science. So I've had a fun few years building houses and things like that. But what I want to do is computer science, and I'm tired of being rejected, kind of like Craig. I'm tired of having an idea that I believe in, which, by the way, I wasn't referring to that. My idea was redoing software from the ground up, not just formally verifying code, but constructing code. So making things like inspiration. I want to do stuff like that. So if you guys think that I could get funding, maybe I could put something on one of these funding websites and put some kind of milestones. I'm all for genuine and legit, okay? But, where does all the money apparently come from and go to? Seems like it's going to Lightning, and what does Lightning do? They make something that's everyone believes in because they think that it's real, but they never even show how the networking works. It's really frustrating because just somebody who's willing to be corrupt, kind of under the table, not be fully 100% genuine, they get all the money. They get all the investment. But if you want to go 100% genuine, 100% uncorruptible, I don't know. But I feel like Craig sometimes he comes across that way. I'm like, that guy's the uncorruptible, So you got different sides of the planet, right? You got all these people doing transactions with each other all the time. And unlike the Lightning Network, you don't need to be connected to the internet. You don't need to be connected to the full nodes in order to pay for all these guys to be paying each other. You don't need that at all. In fact, and it doesn't matter whether you have the Lightning Network or not. A transaction is a transaction. It's a piece of data. So if you want to, you can send a transaction through someone else to the person that you're trying to connect to, right? So there's all sorts of ways you can look at this, but Bitcoin doesn't define how the internet works. It just defines what blocks are. And when you have this as your network that you end up with, you have a very strong system, because all these other systems, even BTC with Lightning or Visa, MasterCard, and all these other, whatever BRICS is trying to do, they can't compete with this system, because this system is actually the lightning fast system. This is the system that's faster than Lightning, because you pay someone directly and they're only going to have to end up checking for a double spend after you've already done that. And if you signed the same coins in two different places, the entire public is going to be able to see that anyway. So they're going to see like where did this come from? You can trace it, right? Just like you can trace crime. Every transaction is private. When I pay someone $1, nobody sees that, but the government can see this serial number is coming in, this other serial number is going out. And that's a decent system. That's not a bad system. That's a system that you want, because you can separate all those things to keep your privacy. We got a bunch of people paying each other, and then whenever they want, here's your global full nodes. Whenever you want, you just update with it. At some point in time, let's say this node disappears, right? So now you got a broken connection here, connection there, right? So that full node gets destroyed. That full node goes out of business. Well, what do you have? You still have a strong system there, and then you have the potential for another full node to come into existence and basically replace whatever that node was doing. Boom. Brand new node. So I'm going to mark this so that you can see. right? That one gets destroyed, but you got a new one that comes into existence, replaces it. That ever happens, people aren't going to have this issue with like these drawings that you get with the Lightning Network where somebody's trying to explain, well, Lightning lets you spread everything out like it's a big mesh. Hello? How many of these thousands of breakpoints are you going to have? Okay, so this isn't the Lightning Network. This is, right, I was drawing Bitcoin, right? But Lightning is going to have a similar, it's going to have like a similar drawing because you're going to have people who have a payment channel set up. They're going to try to come up with these payment channels, but to figure out a routing, how do you figure out routing? How do you have to search, you have to propagate information through all these different channels. Here, these are designed to be parallel enough, thick enough, if you will, if it's like water pipes. These water pipes are thick enough to handle the whole world's throughput. So you don't have to worry about trying to find the closest connection. These full nodes have that already figured out. They only have 2 stops to get to a closer node, you know. Here, you got to go through like 80 steps, and what are you going to do when you're checking if it's 80 deep? How does a breadth first search work for that? You don't know how they're all connected because it's a decentralized network. So unless somebody has all the information of who's connected to who, you actually have to flow through that many different branches. So let's say every time you hit a node, it's connected to 2 other nodes. Well, what's 2 to the 80? Right? How many paths is one transaction? Somebody does a transaction, now suddenly it has to search through 2 to the 80. 2 to the 80 computations splitting from a large, splitting from a lightning node or whatever. Well, duh, that's why the lightning nodes, they end up saying that they're going to look like that. So you see? So the Lightning Network is basically just a way to insert the middleman and make their own privately controlled, like their own kind of the network that they have the papers to. Blockstream is trying to trick you into depending on their system by acting like it's more decentralized, but ultimately they're going to have to take this route. So you can fall for their scam. You can believe their scam, and even when they start using BSV to run all their stuff, you're going to say, no, I don't want to use BSV because Craig's a fraud. But then you're going to have to ask permission. You're going to have to use their system, which they have papers for the Lightning Network, which is still going to be, they're still going to be running it on BSV anyway. And then you're going to pay fees that they're going to keep as middlemen. And they're going to be using what? They might as well use the BSV network since it's already there. It's already cheaper. It's already more efficient. And they're going to deceive everyone into using their system, which is really using the real Bitcoin. It's really using BSV as the base layer. Why fall for that? Why do that? Why not just learn how to use BSV, get your own wallet, and do micropayments, put them on the blockchain so that when you buy and sell something, I mean, how much data, if you're going to go and buy and sell things all day with normal Visa, MasterCard transactions, that's still your entire lifetime. It's probably only going to be a few kilobytes of data anyway. So it's nice, like when you want to keep a log, history log and files in your computer, how much data are you going to accumulate by doing little personal thing, your personal metadata? How much is that going to be? It's not going to be a lot. So having something that's completely off chain, look, I respect the concept of being able to do something like this. I respect the research of being able to shift coins back and forth. That's interesting. And, I'm not against doing research in that type of area, but ignoring the base network is an error. That is a fatal flaw in that system. You don't want to pretend that that problem doesn't exist. You don't want to pretend that, I'm going to have to branch out and send this out to, 2 to the 80. Well, it's not going to be 2 to the 80 because the numbers, you're going to have, cross connections. But if it costs you sending out to the entire network, no matter what, if you have to reach through the rest of the network, you might as well do it with that type of system, because that makes the most sense. And paying someone, yes, it's different than checking for a double spend, but if checking for a double spend is what you need to do, this system doesn't allow you to do direct peer-to-peer, and it will require some other Lightning node. I'll put LN for Lightning node to kind of, figure all that out. Because if it doesn't, and you try to just do it all through routing, you have too many things to check. And yes, they can keep track of information of where did you route last time. And yeah, that's cool research. If they can figure something like that out, all credit to them. I hope they figure those things out. The thing is, even if you pay someone through a system, if they figure out how to route so efficiently that it actually does work, you still don't have your transactions being recorded in a triple entry accounting system. So it's going to be frustrating to deal with that. And like Craig said in this one interview, he was telling this woman, if the government, you don't want the government to have their anonymous coin, their anonymous money, their black money and all that stuff, because they're going to become corrupt. So it's not about you hiding from the government. It's about you making sure the government's accountable, because ultimately what his view is that you actually need the government. And because if the government falls apart, then society starts falling apart, because you need things like justice. Somebody comes and breaks into your house, you need, the law enforcement to help you with that. It's not something you just, suddenly everyone pays everybody under the table, because then a totalitarian scheme comes in. You get people like Mao to come in, and Mao's more dangerous than Hitler, because at least Hitler knows, we're going to take these people's lives. But Mao, he acts like he doesn't think he's taking people's lives, and he ends up killing more people, but he ends up thinking that he's doing it the right way. He's like, hey, do it my way. And if anyone doesn't believe in it, if anyone questions it, those are the people that you take out. He's got everything on an even worse level of evil, because he's still convinced China, hey, read my books. I'm a god and I know everything and I'm always right. And millions of people died because no one's allowed to question him. And he never stopped and thought about, am I actually correct in this? And checking every stage of the process. And that happens with what you're doing and whether you're questioning what somebody else is doing. And that's part of the reason why I wasn't able to propagate my own idea with code editing, because people just assumed that my idea, my assertions, mainly that you don't have to do certain things rather than that you need to create certain things. Like, you don't actually need a parsing stage of compiler to get all these things done. Because somebody questioned, they thought that didn't make sense. That wasn't possible. I wasn't able to propagate my ideas. But if it was up to me, I would hold them accountable and say, look, you're required to check in and prove whether I'm right or wrong. You shouldn't be allowed to just go off and say, well, it's like somebody in a relationship, they hear something and they just assume, oh, this person went behind my back, and they just jump boat because they're not willing to investigate and actually find out if the information is true or not. That's something that we need to do. Which one is decentralized? Is it this one Or is it this one? What is the computer science definition of decentralization? I used to love Wikipedia, but Wikipedia has gotten bad because you look at what is an NFT, and instead of explaining it's a non-fungible token, it says it's some kind of magical feature on a blockchain. That is not what an NFT is. So if you look up on Wikipedia, what is decentralization? Well, Wikipedia doesn't even tell you that Craig Wright was a chief scientist at nChain. So I don't know if Wikipedia is going to tell you. I used to like Wikipedia for learning things about graph theory specifically, but we actually need something that is better kept in check and not managed by someone who's going to censor information and question things that are correct and let math be what it actually is. Decentralization, the word, means it's not centralized. Okay, so by definition, if your graph requires a flow and you want to get rid of this min cut right here, what do you have? Well, you want a complete graph to be the center. Okay, if you need a network like my protocol that doesn't need a blockchain, then you don't need that throughput. You only have peers that transiently connect with each other, and they don't have anything to check for double spending because it's not money, it's just reputation. So in that sense, it's completely as decentralized as you can get because the only thing that they have in common is a protocol. Here, you don't have this centralized complete graph, but you still have the necessity to check for double spends when you're updating the actual base Bitcoin. And you also have the requirement to be able to route the Lightning coins from one side to the other of a contract all the way to who you're paying without the need to create a new contract all the time. And the ability to search for that gives a requirement to collect more information or make larger nodes, which are going to be what? They're going to end up having to connect with and have more information about all the nodes around them. So you're still going to end up having a more highly connected base graph. So with what Bitcoin is attempting to do, this isn't just, we're not talking about trading resources and information. We're talking about trading a commodity that could be sent to the other side of the planet at the same time as a double spend. That's different from a bag of rice and a piece of gold, okay? If I'm sending a gold coin to someone, I'm sending a bag of rice to someone, I don't have to check for a double spend, okay? How do you double spend a bag of rice? Okay, that's something you do on paper, but you don't generate 2 bags of rice, okay? You're not trying to send to this other guy. That doesn't make any sense. So it's for the connectivity. It's not for removing connectivity. So you don't want all these cuts. Max flow min cut algorithm. Look it up. I can't believe it was only created because of like World War II or maybe World War I. But that was so late in the game. Graph theory should be. It seems like it really should have been something that's been around for a couple thousand years, but it hasn't. It's kind of new. So you guys tell me what you think. Decentralized or decentralized? Which one is correct? Are we going with the BTC definition or are we going with the BSV definition? And what does a payment system require? What does Bitcoin require? What does a payment system in general require? I think anytime we're talking about centralizing with these big full nodes, I think that's goofy. Yeah, somebody could try to control them, and that's what SPV wallets are for. Anytime you pay someone, first of all, he knows it's a valid transaction. and then he can broadcast it if none of the nodes are accepting it, because they have to accept it. If they don't accept it, it has to be for the reason of like a double spend. So SPVs, like, I mean, it's a way to check the system. If I'm an auditor and I'm going on behalf of the government to go check to make sure that a warehouse is producing the right things, I'm not as big as the warehouse. I don't have the strength to pick up the warehouse, right? But I can go in there and I can double check and I can look at everything and make sure that they're telling the truth about how many materials are coming in and out, how much diesel they're spending on their trucks and things like that. I can go and check all these things with one little clipboard. That's what a SPV node is. That's what your wallet, your app is supposed to be able to do. It's supposed to be able to certify and check that the information, and these full nodes are always keeping each other's blocks in check anyway by default, as the default. So for them to spend all this proof of work, all this investment into something that they're going to allow something invalid to propagate and then try to build on that, you just built on something that the entire world is going to know. All the wallets in the world will independently be able to certify that that block that you built on is invalid. So think about what that means, the risk. They're choosing to do that if they're going to do that. So it doesn't make a lot of sense. You have a lot of economic incentive built into the system. I want some comments, guys. Tell me. So in 2026, miners will be bankruptcy. Then they find out I am buying more. Such a good trade. Dat when? Why does BGP work on the internet to route for billions of people, but lightning routing could never work? So Brody, are you asking me this kind of sarcastically and saying that lightning is similar, or are you asking me as in you're kind of implying that PGP uses first of all, if you look at a map of the internet, that's a good question, though. I mean, whether you're being sarcastic or not, that's a valid question. But my understanding is, if you look at a map of the internet, you're not going to see something that has a lot of. First of all, if there is a min cut, if you're looking at a map of the internet and you're looking at something that with that, first of all, that's like if you're talking about some of these connection points to across the Atlantic, those don't just go down all the time. If those were to get blown up and those actually went down and they're no longer there to send the data across, well, then you'd have to connect to the internet, through some other channel, or they'd still have to get all that flow to go through. So how many hops does it take let's look this up. So BGP, how many hops median internet? Okay, so online, somebody said something about 4 to 6 hops, and then 8 to 16. So I don't know what he's talking about. I could share my screen with you guys, but I looked up something on Cure. It says, I have done some experiments that found it passes through an average of 4 to 6 autonomous systems and takes 8 to 16 hops. It's difficult to say how many routers are involved in each hop. And so that's somebody asking, what is the average number of routers a packet must pass through on the internet? Keep in mind, when you connect to the internet, they tend to prefer connections that take less hops, because the more hops you're taking, the more somebody's going to have to process all that data and route it through. So obviously, I mean, just thinking about just the graph theory of it, if you're a node, you can only handle so much. You're going to have a limit as to how much information can go through you per second and be sent out to the other side. And so if you're a mesh network, obviously that's not going to get you connected to the other side of the earth very quickly. You're going to have, it's like you have a mesh for the normal, representing people that are just connecting to websites that they usually like to connect to, servers that like to connect to each other because they're neighbors, they're doing business with each other or whatever. That's a mesh. And then think of that as being a subgraph. That's part of the internet, not the entire thing. And then on top of that, you have add some big routers to that, right? Now you got some routers that are like, hey, we're just going to connect Pacific to Atlantic over here, really, with a lot of transcontinental coils. We're going to really send a lot of data across. Now, a lot of these nodes in this mesh are going to be connecting to these more centralized points. They're going to be more centralized in the sense that they have a higher connection rate. So connectivity is a good thing if you can support it. You don't want it like an exponentially high number of connections to every other node in the world where you have the direct IP, right? But you want more connections. But to say, like, it's kind of like an implication when somebody says Lightning is good but BSV is bad, we want it more decentralized. Well, when you take some graph like this and you say, well, this exists, but we want to, no, that's not good. We want to take some of those connections and slice and cut them. But what you've done is you've just created a weakness, and you've actually created a dependency that's more centralized, because now you have some full nodes that are more necessary to be there that you can't remove. So that doesn't make any sense. Their decentralized idea is not describing this, it's describing break that apart. But then you're going to have a central node. I literally saw, I Googled the term decentralized versus distributed or mesh. And they said, okay, this is a mesh, this is distributed, this is centralized. Everything was connecting to the node, not even to each other, just to the node in the center. But then the decentralized one, what the funny thing was, everything was connected to some main big nodes, which were connected kind of in a chain. And they were connected, kind of the smaller nodes were connected to each of those. But then I noticed that if you just removed that one node in the middle, you just split the entire network in half. You just separated a good percentage of the network from completely severed from the other part of the network by removing one node. So you're going to tell me that that's the definition of decentralized? Hello, that doesn't make any sense. Someone else answered his question, and this is 9 years ago, by the way. And he said it greatly depends on what you access, maybe 30, 40 average. Internet is, as you might know, a collection of various devices. So that's a lot of hops. It's not 80 hops. But 30 to 40 sounds like a lot more than what the other person answered, from 4 to 6 and 8 to 16. I'm not a network expert. I just want to take graph theory knowledge and some math and kind of, and in these papers that don't really describe the networking aspect, and kind of present this in as a question, does this make sense or does it not make sense? Looks like BGP was invented, I guess the same day I was born. So cool. That's fun to know. I'm exactly as old as BGP. That's a fun fact to find out here. That's cool. Wow. In-depth tutorials and examples. No, so somebody find out and comment if you know how many hops it takes on average in reality, because I can't find like a good answer here. How many hops for typical internet connection. I'm pretty sure hops. Okay, so the Google AI answers that it's 10 to 12. So that means 11. Linux has a default hop count of 64. And Microsoft has a default hop count of 128. Is that the default number of hops that it tries to take, or is that the maximum? So some other answer is talking about there's a decimal from 1 to 15 that describes how many hops. And they're talking somewhere about, see, I'm just Googling stuff now, right? But 15, right? So the numbers that we're looking at are not that big as like 80. But they are bigger, than like 2, 3, 4. 4 was the smallest number that I saw there for like a typical one. But I mean, ultimately, if you're talking about sending something from like, say, a wallet to another wallet using the nodes, like using information through nodes producing blocks, if you're going to do things that way by sending a transaction and then letting the blocks, not just blocks, but obviously the nodes send the actual transactions to each other quickly. But if you're going to do that, that's still technically 3 hops minimum to go through that. Any more comments? Because I like that question. I don't care if you think I'm right or wrong. I like the question because that's the type of questions. If you're not asking questions like that, then we're not finding anything out. We're not debating anything. It's the problem that I have isn't just that I'm right and that side's wrong. It's that I noticed that there's like a debate that could be happening, and there's also this idea of like, oh, we're just going to censor that person. We're not going to listen to Craig. We're not going to like explain this, why this isn't routing through. What's not happening here. I just want to hear some valid argument on that side and some valid argument of why breaking something like this apart and severing those connections would be somehow better than having something like that, which I think is more dependable and more trustworthy, especially with SPV. I'd rather have something like dependable is almost more important to me personally than like trustworthy and security. That's why I'm against 2-factor authentication being enforced as like a requirement for things like GitHub or YouTube, because if you're enforcing that somebody uses a phone number, which you're trusting some third-party entity that you don't even understand how it works, you can't enforce necessarily through the government. Maybe you can ask the FCC to do something for you, but you're trusting somehow that they're going to keep your phone number coupled with this SIM card in order to access something that is actually just an account for a central hub to store Git certified code. I mean, a Git is a decentralized protocol essentially for code, and it lets you basically make changes easily and structure your changes easily so that you can have different ways of defining how you got from point A to point B via Git, because the way you can combine changes can be multiple ways. You can merge, and then you can make a linear history. All that can be done in Git, and all that can use only the information from the original and then be described as deltas with hashes. So that's not growing information. That's not exponentially more copies of information. That is like minimizing the amount of information that you need to describe all the different versions and patches of code or even updates of code into the least amount of kind of information possible, and it lets it be decentralized to the point where you can download whatever ones of those you want. You can download whatever history of that you want. You don't have to keep all the information, because every single commit has a hash certification with it, has a SHA-256 hash showing what the code state is, what the code, you can't change a single space in your source code without changing the hash. So having something like that bothers me, because I think that it's better to have a system like, if you can have something like BitHub and you can store source code even on the blockchain, it's not going to take up too much data, because how much does it cost to write a commit now? 0.000, like I'm going to pay like 5 cents so that I can write commits for the next couple months. And my commits are always going to be on the blockchain now. They're going to be accessible to everyone. I'd rather have that than have something like, GitHub, where I have to have like this, make sure that they allow me to have access to this account. At least I can see whether I know who's editing the code or not. Those edits, you can sign them with a key, but they can be done anonymously, but you can also certify and check every change that's made. It's not like everyone just has access to do whatever they want, because anyone can change whatever they want, but then that becomes its own version at that point. That's how Git works as a system. In case you guys didn't know, I mean, Linus Torvalds, he made that in like 2 weeks when he was developing Linux. So I appreciate that system that he made. Yeah, no, I love that question. That's a good question. I want to know more about, I didn't even know, you taught me something new by asking that question, because I don't know much about networking, and BGP is a thing, I'm not knowledgeable about it, but apparently I'm as old as BGP. So I should be the expert on it, since we're the same age. Exchange Internet Protocol routing information. And also think that, let me explain one more thing, and it might not answer your question, but the internet itself might make more sense to be structured in a similar way sometimes, depending on what information is being passed around, to what Lightning is drawing out, rather than, I want to call this just a highly connected graph, okay, or it's called a complete graph in an actual math, like graph theory, when all the nodes are connected to each other. Just having a complete graph at the base, that's your center, right? So if you think about Bitcoin, if you pretended that Bitcoin is centralized, then that would be like the mega node, right? And everyone can pay each other independently, and they only connect to that mega node when they're updating. Okay, but the point is that the mega node, the way it's structured, is that it is in its side of itself. When you break it apart, it is decentralized. It's made up of these nodes, which you can pick apart any way you want, and it still is going to work. It's still going to update. Regular internet information might be a cross between that and then my protocol, where you don't need a blockchain. So if you're sending information to other people, or people are checking websites, or websites are connecting with each other because they're doing business with each other, or they're sending information, they're not always, that type of information is not really double spend checking information anyway. So even if you have a couple min cuts appearing here or there, it's not exactly flow, because a flow is implying that you have a source and a sink. Well, when it comes to double check spending, basically all over the network you have sources, and all over the network you have sinks, and they're all assigned to their specific transactions, and they don't know, when you're double spend checking, you don't know where the other sinks are. So it has to be, it basically has to be a a complete graph for that. When you're just sending information around, if you're sending people math formulas and papers and ideas and news articles and things like that, right? That's different. That's going to be information that propagates a little more slowly around, and it's not necessarily going to be exactly the same kind of highly timed, efficient network. I think that's why the original Bitcoin designs that Craig was talking about were called Timecoin, because the whole double spend check problem was a big problem in the past before they had this setup. They didn't know how to really solve that problem, combined with all the other problems with a permissionless system. It didn't make a lot of sense. It was actually difficult to think about how to even solve it. I mean, people thought about these ideas. They knew what a complete graph was. They knew what a mesh network was. They knew what decentralized networks were. They have all this. This math has been around at least, and a lot in the last, at least in the last 100 years, it's been around for a majority of time. But combining those aspects together with like proof of work and things like that to make sure that everything worked together, that was more difficult, because you don't just have, checking for double spends. You have, how do you stop a cyber attack and all those other things together? And then, of course, you have economic sustainability. Thanks, Neo. Love your knowledge and videos. Thank you. And that reminds me, I saw this video. The actor who played Neo, and there was some movie where somebody was coming in, some girls needed some help, and I was like, he's like the only guy you could trust with because this girl needed some help here. Very reasonable thought process here. Thank you. Again, I'm not really teaching a class per se. I'm more presenting a question of which decentralization counts as a good one that we want. Do we want to say this is bad because it has too many connections and we need to slice and dice it up? Because that's what I'm presenting. I'm basically saying, like, if you have a centralized complete graph of full nodes and you say, well, that's too centralized, then you look at the Lightning Network graph where it's all spread out like infinitely wide, right? Oh, he's 3 miles that way on the graph. Okay. But it's the same thing as this almost, except that you've just decided that it's better to separate and disconnect them, which implies that there's going to be some more severing points. In order to connect to someone, you'd have to go a longer or maybe impossible alternate route. And that's centralized in the sense of graph theory because it depends on a node needing to be there now. So this is actually the best way to make sure you're not depending on a specific node. Having it like that actually is a good way to force somebody to depend on a node actually needing to be there. So which centralization do you need? This is in Craig, I don't know if what Kurt said was true, that he has like 180 IQ. Look, I kind of made a poke at Vitalik because I used to see all these thumbnails where people are like 250 IQ, and I make fun of Vitalik for not understanding, for not realizing, I guess, that Bitcoin is Turing complete already, or maybe he knew that, but the opcodes were just disabled on the fork that he wanted to use or something. But like, maybe Craig does have 180 IQ, right? But he's the one who's actually pointing out like the definition of decentralization. And I think we should listen to him because so far, everything that he's said pretty much has been, you've been able to prove it, that it makes sense. Now, I do disagree with Craig. I've listened to one of these talks recently where he said something about artificial intelligence. Cars will never be able to drive themselves. I mean, I've thought about neural networks for many years. I used to tell people about them back in 2010. And I kind of get what he was saying, where he's saying, well, that last 10% is always going to be 100 times more expensive than the previous 90% or whatever. But I don't believe that that's actually the case. I think when it comes to general intelligence, you're not talking about replicating a human. It's called general because it's just general. It means you're not specifying what type of intelligence it is, and a human way of thinking is considered a category, a type of intelligence. We're specifically trained our brains to think in 3 dimensions and time and things like that. We're not good at just processing big Ackermann function computation in our head. So I don't want to get off too much on that tangent, but I want to kind of ask Craig about that and be like, are you sure? Because, I mean, I don't think it's going to be 5 generations down. Plus, I think that self-driving cars that are safer than humans are pretty much around the corner. Yes, they don't think like a human yet. Yes, their brains are still closer to like a spider, but they still do a very good job at things that humans are not good at. I mean, driving a truck from, surprise, surprise, please, Tim, drive this truck from 10 p.m. to 8 a.m. Oh, thanks for telling me at 3 p.m. It's hard for me to stay awake and not crash and get killed. So computer has no problem with that. So, and this is important to mention because communicating with Craig is probably going to be an important deal. So if there is something that I disagree with him on about, it's probably good to figure out how he deals with that. Does he deal with that well? How hard is it to convince him that he's wrong about something? I don't really know because I haven't really had a lot of experience communicating with Craig. I want to read this comment, okay? So salt water is the weak link in those applications. RWA and VR says, but decentralization is for the individual. I don't think for full nodes, a large part of hashing power and information storage will finally be reached, that new data centers will appear. Have you seen Gorilla Pool saying that they're upgrading to Teranode? What they're doing is they're switching over to, see, I didn't understand why. I looked up all these videos because I was like, what's the point of horizontal scaling versus vertical? What's the difference? Why is it cheaper? And I realized it just has to do with the fact that RAM assumes that you need connection. It assumes that you need every part of your memory connected to every other part of your memory, right? But when you're processing a bunch of transactions, they're a tree structure. So you can split it up with the hash. You can say, okay, all the hashes that start with A go to the server. All the hashes that start with B go to the server. Teranode does that, and you might as well do it that if that's what you're doing. So yeah, I don't think that for full nodes, a large part of hashing power. Look, it's peer-to-peer for the full nodes, but what I'm talking about, when we're talking about the protocol itself, to pay one wallet, when you pay someone, Bitcoin doesn't need you to send anything to the full nodes, okay? When you receive money, you want to do that, but when you're paying someone, you pay their wallet directly, you sign the transaction, and you send it to them, and you're done. And Craig even said that. He said, you don't care. Because if they don't want to take their Bitcoin, they don't have to. Your wallet can see later on, and maybe you can try to do a potential double spend. And that's probably why they don't ban you, because otherwise they could trick someone into not spending the Bitcoin until they spend it and then try to spend it. And that's why the nodes, instead of banning you, they're going to just go with whatever the first one they received was, which is smart. Because that way nobody's messing with you. You know, you can still, I mean, you shouldn't have anyone shouldn't be able to attack the network, no matter how they do it. Cyber attacks, whatever it is, they shouldn't be able to mess with you. And listening just to the first transaction and just ignoring the second, and then allowing whoever wants to flag it, that's fine. But the nodes, they have a specific protocol, and it doesn't involve banning people. It involves following the protocol and exactly how the protocol works. It's the way the leftists think. Sorry to get political, but they're always banning people and trying to control who can trade. And you'll notice the Ayn Rand type thinkers are the kind that always try to trade. So Yes or no? Should we continue this longer than an hour? Because we're going to reach an hour, and I think the video is good for an hour, but we can go longer. Or I can do a separate video. Let's do a separate video. We got 7 viewers. I can do another video, and I'll talk about the Trust Me Bro protocol if you want. It's just another idea I came up with. And yeah, person-to-person scaling data, and Satoshi proposed we could generate new data centers.